Now, here's the catch. We can't directly observe volatility in the market. I can't just go to Yahoo Finance, hop on my Interactive Brokers terminal, and check out what volatility is today. It doesn't work like that. Now, we do have model proxies for things like implied volatility. We can proxy for things like realized volatility, but in essence, the process itself is latent. We can't directly observe it. We're always going to be proxying for it. And what I have here is a modified animation. So it's very similar to what we saw up here. But now I have this idea of a latent variance or volatility process. And this is going to drive the volatility of the return distribution as it continues to change over time. I'll play this for you again here. You can see volatility is going to continue to change, and that's going to continue to mold the shape of this unobservable data generating distribution. So hopefully you're starting to get a fuller picture now. Our goal was to what? Originally, we wanted to just model this data generating distribution. We wanted to come up with likelihoods of different states of the world for stock returns. What is the likelihood of a massive loss, a massive gain? We really need to know that information, but now we're starting to see the fuller picture here. Oh, that data generating distribution, it changes over time. Moreover, it's a function of unobservable variables, these latent variables, this latent volatility process. So we need to somehow come up with a model that is capable of capturing all of the dynamics, all of these dynamics in a parsimonious way, something that is effectively going to say something in a more appropriate capacity about the likelihood of different events in these different states of the world. Because when volatility is, say, here it's what, 2.6, the likelihood of an extreme gain or an extreme loss is going to be dramatically different than when it's what, near zero. And that is going to be the function of the model that we develop. We need to be able to capture that dynamic. Some things to note, right? This latent volatility process is not the only latent variable that's going to impact this data generating distribution. The data generating distribution that governs the returns that we actually end up seeing at the end of the day. So we need to keep that in mind as well. If we just model only this latent volatility process, we're certainly going to be omitting other latent variables. Maybe there's this component of trend or momentum, who knows? But it's important to note. Moreover, I said that this latent process was unobservable. Well, then how can we observe it? Here I have an example using realized volatility. We're proxying for this measure using this idea of a rolling window. Essentially what I'm doing is I'm going to look at a 20 or 60 day rolling window for some sort of benchmark mean level. And then I'm going to compute the variance around that window and the associated standard deviation, which is our proxy for volatility. After studying quantitative finance at the undergraduate and graduate level, master's, PhD, I was not satisfied with the transition from academia to industry, which is exactly why I built quantguild.com to help you master your quantitative skills for roles as a trader, a market maker, or a quant in the financial services industry with an adaptive practice engine that scales with your skill level so you can progress to more and more difficult topics. Over 100 hours of lecture content taught by myself, everything from A to Z. We're talking about first principles to the postgraduate level in coding, stats, math, data science, research. The list goes on. Quant Guild is the platform that I wish I had when I was coming up to be a quant, and that is exactly why I built it for you guys. So if you're looking for roles in the financial services industry as a trader, a market maker, or a quant, check out quantguild.com to master your quantitative skills.